Well, hello everyone, and welcome back to Prep 8. So in this problem, Beauty Haven, a popular makeup store near campus, believes that the average price of their best-selling makeup products is lower than the national average for similar items. That's an important word, which is why we bold-faced it. So lower, if we say higher or lower, or over here, less than, that means we've got a directional test. So we'll see that in a second. The national average price for these makeup products is $25 of a known standard deviation of 4. The store randomly selects 30 of their top-selling makeup items and records their prices. At the 0.05 level of significance, they want to test if their average price is less than the national average. So what kind of test is it? It's one-tailed left, because we're looking to see if we're less than. If it was more than, then it would be one-tail right. Distribution is Z. Null hypothesis is no significant difference. But the alternative hypothesis is now directional. The alternative is that we are less than. All right. Let's calculate the average of these items. And the standard deviation of the same items. And the count. And then the national was $25 with a standard deviation of 4. That was given in the problem. All right, the mean is always going to be equal to the national mean. And then the standard deviation is going to be equal to that divided by the square root of n. Okay, let's go a little bit further before we check out the graphs. So we'll take this minus that. And then our z-score is going to be equal to the observed difference divided by the standard error. And here's our z-value way out here. So it's certainly looking like a reject. If you look, like here you're in the tail, deep in the tail, here you're deep in the tail. In fact, here we actually know it's a reject because it's already calculated the p-value for us. But let's see if we can get that same calculation ourselves. So that's going to be, let's see, we've got a negative and it's directional. So it's one tail left. Z-score can be negative or positive, it doesn't matter. It's just going to be straight up norm.s.dist. All right, and alpha is 5%. And so we've got our norm.s.inverse probability. Drag that across, fix it here to 1 minus for the right-hand side. Drag it across. And then let's get our confidence interval. So we start out with the mean. Where's our mean? Here. We build the confidence interval around the sample mean. So it's that minus the standard error times the two-tailed right critical value z-score. And over here, plus the standard error times that value. And if you're wondering, well, why is that the calculation? Here's the logic behind it. Here we've got x bar. We basically want to see how many standard errors away we should go. Right? How many standard errors? Remember, these standard errors is the distance between any of these blue lines. So how many standard errors should we go for 95% confidence? And the answer is for 95%, you've got to go almost 2 standard errors, 1.96, that magic number, standard errors. You got to go that far. So you've got that many standard errors that you got to go. This is how big each of those standard errors is, and that's why it's that multiplication. And there's our confidence interval. So we're sitting in here. It does not include the population mean. So again, further evidence that this is for sure a reject the null. But I actually think you can do this one without me, especially since it's a reject. So I'll let you take a stab at that. And let's look over here. What does the result of this one-tailed z-test indicate about Beauty Haven pricing compared to the national average? Well, we're less. So that's great. HA is directional in a one-tailed test. If we reject H0, the conclusion has direction, right? So the conclusion is that it's actually the same as HA, right? It's that we're less. If the confidence interval does not include the mu of the null, what can we conclude? And it doesn't in this case. So we reject the null hypothesis. In this example, the upper bound of the confidence interval corresponds to what type of error? So here's the upper bound this time of the confidence interval. What kind of error could that correspond to? It could correspond to a type 1 error. And here's why. Because the upper bound of the confidence interval would be less than 2 standard errors away from the population mean, right? It looks like about 1.5 standard errors away from the population mean, or the mean of the sampling distribution, which is outside of the rejection region, right? You can actually see it here, right? Because here it'd be 1, like 1.5 would be around here, and the rejection region starts a little bit further. So, so that would be a type 1 error, because type 1 error means that we reject the null hypothesis when in fact it's true. So for a z-test, does the height of the black dot matter? Now we're asking about the black dot, not the red dot anymore. And the height of the black dot matters a lot, because the height of the black dot determines how skinny the population standard deviation is. And it's this black line. If this black dot was higher, then this would have a smaller standard deviation, and if it was lower, then the population would have a larger standard deviation. And since the population standard deviation is used in a boatload of calculations, here I'll prove it to you. Say I change it from 4 to 5, you can see that all these calculations are immediately influenced by that. So the height of that dot for sure does matter. I'll undo that to bring it back. And so yes. Now we have to say, why does it matter? So higher would mean smaller population standard deviation. That's the important one. Once you get that, you know the rest of this is true also. And we get all our points. And so what we're effectively saying is we're rejecting, which means that we think that the sample belongs to a different population, not part of the blue population. And remember, don't forget to answer these. I'm very confident that you'll be able to. And that's it for now. Thanks.